back to the deep dive. Our mission, as always, is pretty straightforward. Give you that high-speed shortcut to understanding the really critical shifts happening in AI right now. We've been tracking, these 10 key developments, the ones set to take AI from just being a cool proof of concept to essentially being infrastructure level in the next, 5 years or so. We've already covered quite a bit.
Yeah, things like foundation models as a service, self-supervised robotics, AI-generated data, neurosymbolic engines.
Personalized assistance, AI in drug discovery. A lot of ground covered.
Right, big stuff.
And today, we're hitting number 7, and this one, well, it feels like maybe the most disruptive from a policy standpoint, regulatory compliant, explained by design models.
Yes, the anti-black box.
Exactly. It's the necessary counterpoint, isn't it, to that whole black box problem that's basically stopped so many AI projects in their tracks, especially in high-stakes areas.
Yeah, it really has. It's where, good engineering principles finally meet the reality of regulation, those older black box models. Super high performance sometimes, sure, but you put data in, get an answer out, and have kind of no clue how it got there.
Right.
Well, that just doesn't fly for critical infrastructure. I mean, if you can't verify how a decision was made, you fundamentally can't trust the system. Not really.
And this isn't just theory anymore, is it?
Oh, definitely not. We're actually in the standards drafting stage right now. This is happening through 2024 into 2025.
So the clock is ticking.
It absolutely is.
Yeah.
The timeline looks pretty fixed. Sometime between 2026 and 2028, this explained by design approach. It's expected to be mandatory, non-negotiable for anything classed as a high-risk AI system globally. Think EU AI Act, for starters.
Okay, let's really unpack that difference then. What exactly makes a model explained by design? How is this proactive approach different from, the usual scramble to figure out why some opaque system did what it did after the fact?
Yeah, that scramble, it's often pretty messy. The core difference is architectural intent. It's built in from the start. Think of it like, a plane's black box, right? It records data, but you only really look at it after a crash.
Right, reactive.
Exactly. An explained by design system is more like having real-time diagnostics on every single part of the plane navigation, fuel, hydraulics, all feeding out human-readable information as it operates. It's designed for transparency during flight, not just post-mortem.
Okay, so it's baked in.
Completely. These AI systems are deliberately engineered, right from the initial coding, with interpretable elements built right into their structure. They don't just crunch data and give you a probability score. They're designed to naturally produce explanations, things humans can understand, as a standard verifiable output.
That feels like a fundamental shift. Moving away from trying to reverse engineer a decision, which, let's be honest, can be pretty hit or miss.
Often very hit or miss, yes.
To actually building interpretability in from the get-go. Can you get a bit more specific for us? What kind of built-in elements are we talking about here? What does this architecture actually look like?
Sure. So this clarity comes from specific features, right? Woven into the model. It's about moving away from those giant monolithic neural networks where everything's kind of tangled together towards structures that keep things clearer at key points. The 3 big examples you see popping up again and again are attention maps, causal graphs, and rule sets.
Okay. Attention maps. I think I've heard of those, especially with language models.
That's exactly right. They're very common there. An attention map, well, it visually or numerically shows you which specific parts of the input data the model paid most attention to when it reached its conclusion.
So, like highlighting the important words.
Pretty much. Imagine an AI reviewing, say, a loan application. The attention map would highlight the exact sentences or data points, maybe high debt-to-income ratio, maybe a specific employment history note that made it flag the application as high risk. It gives you an immediate kind of visual audit trail. You see what it focused on.
Okay, that definitely makes things clear. It's like watching a jury and seeing which bits of evidence they kept coming back to. What are the other 2 you mentioned? Causal graphs and rule sets. They sound a bit more involved.
They are, but they serve different important functions. Rule sets are probably the simplest to grasp. Think of them as programmed guardrails, explicit logic gates within the AI.
Like if this, then that.
Exactly, like if this, then that. They ensure that for certain decisions, maybe legally mandated ones, the AI must follow a clear, human-defined, often regulatory logic. So if an insurance claim has to be rejected based on a very specific policy clause,
the rule set just executes that.
Precisely. The rule set handles it, and the explanation is straightforward. Decision made based on Policy Rule 7.2b. It's deterministic, totally transparent for that specific step.
Got it. And causal graphs, you said they were fascinating.
They really are, because they try to go beyond just finding patterns, beyond simple correlation. Causal graphs are designed to actually model the cause and effect relationships the model learns from the data.
Okay, how does that work in practice?
Well, take medicine. A standard neural network might spot that symptom A and symptom B often appear together with disease X correlation. A causal graph, though, is built to try and understand the underlying mechanism, maybe that symptom A causes symptom B, and it's the combination that leads to disease X.
So it's trying to map the why.
Exactly. So when the model makes a recommendation, the causal graph can provide a chain of reasoning based on these understood or learned causal links, not just statistical association. It's a much deeper level of explanation.
Okay, that technical stuff lays the groundwork really well. It explains the how. But now, the really crucial bit, the so what? Why does all this explainability actually matter outside of a computer science lab? Is it just adding cost and slowing things down, or does it fundamentally change the game for businesses and institutions?
Oh, it fundamentally changes the game. It's all about risk. Explainable AI, or XAI as it's often called, is vital because it directly tackles massive, sometimes even existential organizational risks.
Existential. That sounds serious.
Well, think about compliance failures, legal battles, security breaches, massive reputational hits, all stemming from an AI system making a bad call that nobody could foresee or understand. Imagine a critical system, maybe running logistics for a national grid, or approving large-scale loans, if that fails silently or makes biased decisions.
The fallout could be huge.
Devastating. So XAI helps mitigate all that. It allows for proper model auditing, it builds trust with end users, which ultimately is what allows AI to be productively used in these high-stakes environments where, frankly, the fear of the black box often led to just paralysis. Nothing got deployed.
Okay, but let me just push on that a little. Isn't there a trade-off? Isn't explained by design basically a tax on performance? We've always heard that the most accurate models, the ones that really perform, are often the most complex, the most opaque black boxes. Are we forcing companies to choose between being efficient and being compliant?
That's the million-dollar question, isn't it? And yes, that is the core tension driving a lot of the current research. It's a very fair point. Historically, there often was a trade-off.
So are we losing accuracy?
Sometimes, yes. Simpler, more interpretable models might not quite reach the peak performance of a massive, complex black box on certain narrow tasks. But the calculation has changed. The industry, pushed by regulators and by risk aversion, is basically saying that peak performance without accountability is becoming an unacceptable liability.
The risk outweighs the slight performance edge.
Increasingly, yes. The practical impact is really twofold, and you just can't avoid it anymore, especially when you look at the legal side.
Okay, tell us more about the legal angle. You mentioned the EU AI Act.
Right. First, legally speaking, explainability is essentially the passport for AI into regulated markets. It's absolutely fundamental to meeting those transparency requirements in the EU AI Act, particularly for systems classified as high risk.
And high risk isn't just anything, right? There's a specific list.
Exactly. It's clearly defined. We're talking AI used in critical infrastructure power, water medical devices, anything deciding educational admissions or hiring, credit scoring, law enforcement, border control. Really sensitive stuff.
Makes sense.
And for those systems, the EU AI Act demands robust documentation, human oversight capabilities, and explained by design is the technical mechanism to actually deliver on those demands. If you meet those EU standards, you're not just getting into the European market, you're basically setting a global benchmark that helps navigate rules popping up elsewhere too.
Okay, that's the legal stick. What about the carrot? You mentioned trust as the second big impact. That feels huge, especially in areas like finance or healthcare.
It's absolutely huge. It boils down to basic user confidence. I mean, imagine you're a doctor. An AI diagnostic tool suggests a pretty serious treatment path.
You'd want to know why.
You'd need to know why before you act on it, right? Or if you're denied a mortgage by an AI, you deserve to understand the factors involved. Explainability directly builds that necessary trust, particularly when the decisions have really significant human consequences, financially or medically.
And you also mentioned earlier that this clarity can actually influence whether projects even get funded internally.
Yeah, that's a very practical point. Think about it from a board's perspective. They're managing risk.
Yeah.
If someone proposes a major investment in a new AI system, maybe scaling up a supply chain forecaster or developing a new diagnostic AI, that proposal is much more likely to get the green light if the system can clearly explain its reasoning.
Because the board can understand the risk better.
Exactly. Nobody wants to pour millions into a powerful but totally opaque system when they know strict regulations and potential lawsuits are just around the corner. Explainability becomes a prerequisite for investment confidence.
Okay, so the benefits are clear, the legal push is strong. But these AI systems, especially things like foundation models, they can be incredibly complex, technically massive. Does this explainability requirement really apply to every single algorithm? And how do you even make something that huge truly explainable in a scalable way?
That's a really important point, and it brings us back to that high-risk classification. The short answer is no. Not every piece of AI needs this intense level of built-in explainability. Your streaming service recommending your next movie? Probably not.
Okay, thankfully.
Right. But here's the key insight. Without XAI, a huge chunk of AI's potential can't be reliably or safely used where it matters most in critical decision-making roles.
So XAI unlocks those high-stakes applications.
Precisely. It meets that fundamental demand for reliability. It allows the users, the decision makers who often aren't AI experts themselves, to actually grasp the why behind a complex model's output. And if you zoom out, think about governance. Explained by design is what transforms potentially dangerous, opaque models into tools that stakeholders can actually trust, verify, and govern responsibly.
And when you say stakeholders, that's a really broad group, isn't it?
It really is. We're talking about everyone from the internal technical teams debugging the model right up to external regulators checking for compliance. But critically, it includes the end users, too.
Like the doctors, the loan officers.
Doctors, loan officers, maybe even jurors interacting with AI-presented evidence, customers wanting to understand a decision, regulators checking for bias. XAI lets them see how a decision was arrived. That allows them to assess if it's relevant, spot potential errors or biases, ensure it complies with fairness laws.
And you mentioned it helps the tech teams, too.
Definitely. That transparency makes debugging and improving the models much faster and more effective. And ultimately, it just paves the way for adoption in all those safety-critical fields, healthcare, finance, justice, where things like accountability, fairness, and the ability for humans to oversee and intervene are absolutely non-negotiable. It fits right in with existing ideas, too, like the GDPR's right to explanation. So this push for transparency is clearly transformative. But, we have to be realistic. It's not without its hurdles. It introduces some pretty significant trade-offs, technically and practically, which kind of begs the question. What are the main challenges standing in the way of getting these robust explain-by-design systems everywhere they're needed?
Yeah, the reality check. The sources point to some substantial limitations, falling into maybe three main buckets. First, the one we already touched on. The performance gap.
Right, the speed versus safety trade-off.
Kind of. By their very nature, because they might need simpler structures or extra logging components, explainable models can sometimes lag behind the pure black boxes in raw metrics like speed or predictive accuracy on certain benchmarks.
So there is still a bit of a penalty sometimes.
Sometimes, yes. Think of it like, well, the fastest possible car might be a stripped-down racer with zero safety features and terrible visibility. It's fast, but you wouldn't drive it on the street. An explainable model is more like the safe, road-legal car. Maybe slightly slower off the line, but you can see where you're going, and you trust it not to, inexplicably veer off the road. Research is working hard to close that gap, but it's still a factor companies weigh up.
Okay, performance gap is one. What's the second challenge?
The second is more about the, let's say, technical integrity, specifically the quality of the explanation itself. And here we really need to distinguish between explanations generated after the fact, those are called post hoc methods, and the kind of innate explanations that come from a true explain-by-design system.
So explaining after the event versus explaining as you go.
Exactly. Using a post hoc method can be a bit like asking someone why they chose their career path 20 years later. They can give you a very logical, rational story now.
Sure, it makes perfect sense in hindsight.
Right. But that neat story might completely miss the thousands of tiny, random, complex, maybe even subconscious factors that actually drove the decision when they were, say, 19. The post hoc explanation can sometimes be, well, a plausible fiction. It doesn't always fully capture the model's real internal reasoning, and worse, it can sometimes be actively misleading or just a massive oversimplification.
So the explanation might sound good, but not actually reflect reality.
Precisely. And that leads straight into the third big challenge, which is more of a human cognitive risk, the danger of over-reliance on these explanations.
Meaning people trust the explanation too much.
Yeah. If an AI system gives out an explanation that seems clear, simple, logical, but is actually one of those misleading, plausible fictions you mentioned,
The user might just accept the AI's output without enough critical thought.
Exactly. A doctor, a judge, a loan officer. They might overtrust the AI's conclusion simply because the explanation sounded reasonable and easy to understand, even if the underlying reasoning was flawed or the explanation itself was incomplete. It's a real risk of misplaced confidence.
It's tricky. And I guess tying all these challenges together is the problem of, well, standard.
That's the final piece, yeah. The standardization challenge. It's massive. If Company A's attention map worked totally differently from Company B's, or if there's no agreement on what constitutes a sufficiently detailed explanation for regulatory purposes,
then the whole framework starts to wobble. How can regulators enforce anything consistently?
Exactly. There's a huge ongoing effort needed to create industry-wide benchmarks, metrics, and certifications to clearly define what actually qualifies, both technically and legally, as proper explainability. Without that, it's going to be very difficult to implement and enforce these rules effectively.
Right. So pulling it all together, despite the challenges, XAI, this explained by design movement, it really isn't just a nice to have. It feels more like the essential bridge, doesn't it? It's what can take this incredibly powerful but often opaque technology and turn it into something transparent, something verifiable, something we can actually hold accountable, especially in those high-risk, safety-critical situations.
Absolutely.
And without this kind of compliance infrastructure getting firmly established, probably by that 2028 kind of time frame, you could see AI deployment just stalling out indefinitely in some of the most important sectors where it could do the most good.
It really feels like a fundamental shift, moving from just chasing the highest accuracy number to focusing on the trustworthiness of the entire process. It's redefining the contract between AI and society in a way. And that brings us, as always, to our final thought for you, the listener, to maybe chew on. We've talked about the risk of over-reliance, how explanations, especially those post-hoc ones, can sometimes be misleading or too simple. So here's the question. How will future regulations ensure not just that an explanation exists, but that the quality of that explanation, its scientific validity, its logical soundness, is actually good enough for genuine accountability? How do we make sure the explanation itself is trustworthy? Something to think about. Thanks for joining us for this deep dive. We'll see you next time.
Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.